That's it? Okay. I thought there would be an intro. Thanks, everybody. I have to say, my MacBook updated last night, and I have a live demo. So it could work, it should work, but it could also explode. And I'm not sure, we'll have to see what happens. I've been talking to people, outside throughout the conference, and I think people are pretty excited to be here. Are you guys excited? Are you happy? Okay, nice. Everybody's been inside for 2 years, and then they come outside and they're so happy to meet other people and to have conversations about tech. And I'm happy too. And I'm also happy because I think what my feeling is from the other talks I've seen here and from the other conversations I've seen here, that we are talking a lot about how we handle data in React applications. So we heard a talk about XState and React Query and Mobix. And I also want to talk about how we handle data in React applications, so it works really well for me. But I want to suggest something slightly different, because what I want to suggest is building a different mental model of how we think about our data, and switching from this paradigm that we have right now that we're used to, where data is static, to a paradigm where data is dynamic and it changes all the time. I'm going to talk about it a little theoretically, and then I'm also going to show it in action, or show an implementation of it with an app where the UI layer is built with React, and the data layer is built with RxJS. So that's what we're doing today. Let me tell you who I am so that you're not confused. This is me in black and white. My name is Netta. I'm a senior front-end developer at Tikal. And if you know what Tikal is, you know that we are a software expert company. So we help other companies address tech challenges. And so I'm also a web platform engineer at Zensity. I love Twitter. This is my Twitter handle. I'm very active on Twitter. I've been added to all the lists, the feed tech lists. So feel free to follow me and reach out to me. And if you have any questions or you want to talk about this, I'm on Twitter. Okay, so we're talking about this idea of data as being dynamic rather than static. And I want to start by talking about what it isn't. So the way we model data in our applications today is we say we have data that is persistent. Right? We have state or whatever, we have a cache, and this data persists over time. And then our job as developers is we go in and we build the ways in this data changes. So when we need to change it, we go in, we create a setter, we create an action, we do what we need to do in order to change our data. And this paradigm comes to us from the backend. Now, who here was in Gil's talk earlier today? Gil was in Gil's talk. Okay, there's like 5 people. But if you went to Gil's talk, you heard him say, well, if it works for the back end, it works for the front end. If it works for the back end, it works. Does it? Because what happens in the back end is, in the back end, we have a database. We have this source of data that's supposed to persist over time, that we want to be very deliberate about the ways in which we change it. We want to be very controlling. We want to be very controlling about the times when it doesn't change and who gets to touch it and who doesn't get to touch it. And that data persists over time. That database persists over time. But in the front end, by the way, Gil's idea of micro front ends definitely, I believe, works for the back end, works for the front end. But this idea of static data, not so much. And I'll tell you why I think that. Because a front-end app, by definition, is a series of changes and reactions. And what do I mean by that? Well, what happens when you navigate to a page in the browser? Our code, if we write front-end, our code loads into the browser, right? And then it sits there, right? It sits there and it waits. What is it waiting for? It's waiting for an event, either a user event or a response from the server or even a timer to go off, right? But unless an event happens, nothing runs. Nothing runs in our code. And then, once an event happens, we need to start trying to deal with that. And when we model our app as static data, then we have to be very deliberate and wordy about what we do when an event happens. Because now we've taken the world of events, we've modeled it as static data. Yes! Unexpected things happen. We've modeled it as static data. Now an event happens in our app. We have to go and we have to change that static data, right? Then our app needs to support another kind of scenario. Inevitably, we always have a new feature. We always have another type of scenario we need to support. So then we need to go in and we need to add that mechanism of change. And then something else comes up and we need to add that mechanism of change. And sometimes they interact with each other, right? So like we have two places and they're changing the same data, or we have the same data coming in and it affects two places. And every time that happens, we need to go in and we need to write that code because we've modeled that data as being static, rather than modeling our app as being a collection of changes and reactions. And if this sounds too theoretical, or you don't know what I'm talking about, just think about filters. Because in all my years in Frontend, and I've been in Frontend for 10 years now, I can tell you for a fact, the story of filters always goes the same way. If you build a set of live filters, so you build a set of filters where the UI gets updated automatically on any selection, what happens is you build those, 6 months down the road, nobody knows what's going on, nobody wants to touch them, everybody's scared of them, everybody's sure that if you go in and you change one thing, that whole part of the system is going to break down. And that's because we've taken filters, changes, events, and we've modeled them as static data. And so I want to suggest a different way of handling our data in front-end apps. Specifically, it's very different for React. There's an implementation of this exists in Angular 2 since Angular 2 has existed. But I want to suggest handling our data through observables, through a type that is designed to represent data changing over time. And in fact, it's designed to only have data on it in a specific moment in time. So that's observables. I'm going to show RxJS, but I do want you to know that RxJS is just an implementation. It's currently the most popular implementation, but there are other libraries. There's a proposal for TC39 for a native JavaScript observable. And so let's try and think of observables as a concept or a type rather than a specific implementation. OK, so we're going to look at React and RxJS. I think I might need to do some dive into RxJS, but I want you guys to tell me. So let's have a show of hands, class. Please raise your hand if in the past you've worked with observables. Not observable state in Mobix, but the observable type. OK, so I got like 10 of you. That's not too bad. 2 more here. Thanks, guys. So I'm going to look at the basics just a little bit, like just explain the basics of that system a little bit, and then we'll look at some more real-life code. OK, so observable, a type that's designed to represent data changing over time. They are a push system, so that means that they emit values to their subscribers, as opposed to like a function that is a pull system, right? You have to call it in order to get the value from it. They are recurrent, so that means that they emit multiple values over time, as opposed to, say, a promise that's push-based, but it only emits once on the resolve. They're lazy, so an observable needs to be subscribed to. It needs to have something observing it. If it doesn't have anything observing it, it'll never do anything. And then last but not least, they're first-class citizens in systems like RxJS. And I'll explain what first-class citizens is. It means that you can do whatever you want with them. They're like a primitive. You can save them to a variable, you can return them to a function, you can save them to a property on an object. So like whatever you could do with a string, you could do with an observable in these types of systems. And this is really important because this is the property that allows us to have to make use of the other component in this system, which is operators. So operators are pure functions. They take an observable as an input, they return an observable as an output. And they allow us to do two things to the observable. They allow us to modify the value it's emitting. So that can be something as simple as mapping one value to another value, or something much more complex like merging values from two different observables and then emitting both of them together. So they modify the value, and then they can also modify when an observable emit. So that can be something like a filter, saying only emit under these and these conditions. And it could be, again, something more complex, like saying, well, don't emit from this observable until that other observable has emitted, because I need both those sets of data in my UI. Okay? And then what observables and operators allow us to do together is they allow us to model data as a pipeline. Okay? A change happens, say my data comes in, and then I do all sorts of things to it with my operator, and in the end it's going to be passed to whoever needs to consume it. And so I often like to think, and you'll hear me say this too, I like to think about my data in RxJS as streams. Streams of data where I've set the course, I've told it which way to go, I've told it what to do, and then the data comes in and it just flows to its destination. And the destination is the third component of the system, which is the observer. It's where you get your data. So this is the thing that subscribes to the observable. It only needs to be or to have two things. It needs to be an object, and it needs to implement a next method. In that next method, we get our value. We are able to hook that up to our UI. And so our data layer, when working with RxJS, will always follow this pattern. An event happens in my app, right? User event, response from the server. I pipe that to a series of operators to modify the value, to modify when it emits. And then in the end, I'm going to subscribe to it. I'm going to use my observer to pass it to my UI. And you'll notice that two things are true by default for this system. One is your UI layer is completely separate from your data. Noah's also said this in her talk, and I want to iterate on this. So when you're working in this way, you are going to have to work really hard to modify your UI in this pipeline. You're going to need to really not know what you're doing if you're going to modify your UI somewhere in this pipeline. So they're completely separate. And then the second thing is the UI is 100% a derivation of the data, because the data flows through, I get it here, I subscribe to it, I pass it to my UI. So the UI is 100% the derivation of the data. Okay, app time. Let's look at our demo app. And this is, in fact, looks a lot better on my screen, and also is a watered-down version of our dashboard at ZenCity. So what we do at ZenCity is we help local governments get insight into what their residents are thinking. And one of the ways we do that is through monitoring and analyzing traffic on social networks. So we'll pull in all the threads from Twitter, say, about some city, and then we'll do all sorts of analysis on that data. One of the analyses we do is a sentiment analysis, and that's what you see here. So, can I? Yes. Positive sentiment, neutral sentiment, gray and very difficult to see, and then negative sentiment. And so I have one source of constant change in my app at ZenCity, because I'm polling the backend every 5 seconds, and I also have a job that's constantly running and pulling in data from these social networks into my backend. And so you can imagine that for a large client, there might actually be different data every 5 seconds. Every time I go to the backend, there might actually be different data. So that's one source of change to my app. And then another source of change is these filters right here. So I can throw things on the floor. Never mind, I don't have a clicker anymore. So I can filter by source, okay? So I can decide if I want to show Facebook or hide Facebook. And then I can also filter by sentiment. So I've clicked here to hide the, there it goes, to hide the neutral sentiment, and I can hide the negative sentiment as well. And I can also decide to show them. Okay, so one source of constant change, my data, this, okay? And one source of constant change from my user end is the select, deselect on the filters. Okay, let's start and look at how we model or how we work with polling with data from the backend. This is my code. In order to poll the backend, I'm going to have to start with setting up an interval. Is this big enough? Yes? Okay. No? I didn't hear you, and so I'm just going to make it bigger, just in case. Okay, so I'm going to have to start by setting up an interval. I do that using the timer function. This is an RxJS function that creates an observable that emits an integer every whatever duration of time I tell it to. So I told this timer to emit immediately. That's this 0 right here, and then emit again every 5 seconds. Now, I'm piping that to the share operator. Because I'm doing that, I'm going to tell you what it is, but it's kind of a detour. Observables are, by default, unicast. That means each subscriber has their own copy of the observable. And so if I create an observable that emits random numbers, and I set up 2 subscriptions, I'm going to see different numbers on each subscription. But when I'm using observables for data in my front end, I often want to cause them to not do this, to be multicast, to cast the same value or emit the same value, the same data, to multiple components. And that's what the share operator does. And I'm using that because I'm going to use this one interval to create 3 different streams of data, 3 different requests to the server for each of my connectors, Facebook, Twitter, and Instagram. I create those streams in this function here called generate data stream. We are ever so lucky to, right off the bat, land on the holy grail combination of RxJS, which is the combination of the merge map and the switch map operators. And I'm going to take a few moments to talk about that because I think this is one of those things where thinking about data as being dynamic, thinking about data in observables becomes very tricky on the one end, but also the value of it becomes very clear. So I'm going to do it using bubble diagrams. If you guys have ever seen RxJS documentation, you've seen these. We use them to explain so many things, and that's because they have a timeline sort of representation in them, and they also have a value representation of them. So this is an observable emitting yellow bubbles over time. So my timer observable would look something like this. Okay, it's emitting integers over time. And now I want to see what happens with my merge map observable, or my merge map operator. What merge map does is it takes each value emitted on the input, each of those numbers we just saw, and it maps each of those values to an observable. In our case, it's an observable that's created using from fetch. Again, that's an RxJS function. So what it's going to do is it's going to make a server request. It's going to emit the response. And so what we're doing here is we're taking this stream, and we're mapping it to this stream. We're mapping it to an observable that emits other observables. And we can do that because observables are first-class citizens. We can emit them on other observables. The only problem is, if I were to subscribe to this, what would I see? Observables. And I don't really care about the observable. What I want to see is the values emitted on the observable. So what I want to do to it is I want to do this. And I do that using switch map. You can see that right here in my code. Okay, switch map gets the response from the from fetch internal observable, and then it just returns the response body, and it also does some error handling. Okay? And the thing about switch map is it not only does this flattening of the observable, but it also makes a specific decision about how to flatten that, and in particular, it makes a decision about this case. Because what we have here, see my second response went out here, but there's some kind of lag. And it returned after my third response. But what switch map does is it will always switch to emitting the values from the latest internal observable. So once it runs into this case, right, where the second emitted after the third, it's only ever going to look at the latest observable. So it's only ever going to emit this. So when I flatten it out, it's going to look like this. Remember, I had 5 requests. I'm only ever seeing 4 responses. And what that does by definition is it makes sure that the data emitted on this external observable is always the freshest. It always comes in from the most recent response. And if there's any lag, if there's anything weird going on in the middle, I, the developer, I don't have to handle that, okay? Because switch map is going to do it for me. And that's why this combination of switch map and merge map is a little bit difficult to reason about, because it's observables and then it's strategies over time, but it's also very, very powerful, and we often use it for making server requests. So this is my stream of data. I want to hook it back into my UI. I'm going to do that in this hook right here that's called useDataStream, and in this initStream function. I'm saving my observable to a ref so that it persists across component re-renderings. I want this stream of data to persist across re-renderings. And so I'm creating a ref here called subscription. And then I'm using this generate_data_stream function to save it to the current, to the current property. Now, if I only had this line in my code, this line right here, what would happen to my code? Nothing. Right, because, remember, observables are lazy, and in order for them to emit, we have to subscribe to them. And so I have the subscription right here, and remember we said when in our subscription, we're just hooking into our UI. So we're calling setState, that's a regular React useState hook, and then my hook, this useDataStream hook, is exposing that state. That state gets passed into my UI component, and so every time that stream emits, my UI component is going to get updated. And I don't need to do any of the work of going into my static data, telling it that something changed, telling it how to change, telling it how to deal with the new data. All of that is handled through this pipeline of changes. Okay, so this is how we fetch our data. That's creating these 3 kind of widgets right here. Now let's have a look at our filters, and let's start with our connector filter. So the connector filter is this one, right? It's the one that tells me to show Facebook or hide Facebook. And now that we know that we've modeled our data as a stream, we know that in order to hide one of the representations of that stream, all I have to do is turn it off, right? I got to turn off the faucet. How do I turn the stream off? Unsubscribe, that's right. Okay, remember, observables don't emit unless subscribed to. So in order to turn an observable off, all I have to do is unsubscribe from it. And that's exactly what's happening in this stop stream function. I'm resetting my state just so that my UI gets reset, and then I'm calling unsubscribe on the stream. And again, this is the full kind of end-to-end flow of going to the server, getting data, updating my UI, and then also stopping that polling mechanism whenever I need to. So that's pretty cool. That's fun. That's like, yeah, RxJS is cool. It's nice. But let's get into our sentiment filter. And you know, when I started working on this filter, I said to myself, okay, so it's a sentiment filter, right? There's an event, select, deselect. I can get the value of the filter. I can get the select, deselect value from the event. That's no problem. I can know what happens with one filter, right? But I've got 3. And I want to always remember about the other 2 that haven't had the event on them right this moment, whether they're selected or unselected. Like, I have to keep track of this. I have to keep track of the state of my filters. And so I thought to myself, I need persistent data, like I need it in my app. Look, I have this filter problem and I need persistent data, and that goes against everything I'm trying to say here. And so it made me cry. But then fine. And then I went for a run, and I thought about it again. And I said to myself, wait. It's all just events, right? I know sometimes when I talk about it, I sound a little bit like a stoner because I'm like, it's all events, man, it's all events. But it's all just events. And the thing is that is a property of my app. My app is always events and reaction to events. And it doesn't matter which code I write. It doesn't matter how I model it, because that's what my app is. My app is events and reactions to events. And where there's an event, I can create a stream. And if I can create a stream, I can model this in RxJS. And so that's what I did. I created a stream using a subject. A subject is both this is also an RxJS utility. It's both an observable and an observer. That means it can emit values, and it can also subscribe to other observables. And the reason I want to use this is because I want to emit the value of the filters, but I also want to subscribe to the observable created from the event on the filter. And so we're going to model that using not a bubble diagram, but a bubble graph. What do I mean? Okay, this is my subject. Again, this is always emitting the most recent filters. This is always emitting the updated filters. This is going to hook up into my data and tell my data, show negative sentiment or hide negative sentiment, right? Or more precisely, pass negative sentiment to the UI component or don't pass negative sentiment to the UI component. Then I have this other observable that's created from the event on the filter, okay? Now what I want to do, because I don't have static data, I only have data that exists in specific point in times, is I want to have my filters data, my existing filters data, and the data coming in from this event, I want them to exist in the same place at the same time. And so I need to pull this filters data, wrong, into my event stream. So I pull the filters data into the event stream, and now I have the selected filter and the existing filters, and they're at the same place at the same time, and I can use them to calculate the value of the new filters, and then I'm going to subscribe this original subject to that stream so that this original subject can also emit the updated filters so that they can be passed to my data stream. Let's have a look at this in like pseudo-ish code. So I create a subject that emits my latest filters. That's fine. Then I create an observable that emits the selected filter on the event. Now I'm going to pipe it, and I'm going to use this combination of operators with latest from and map. What with latest from does is it pulls in the value emitted on this latest filters subject. Okay? And so now I'm at the state where I have the most recent filters, I have the selected filter, and then I use the map, and this create new filters is just a mapping function. So it takes those two values and creates an object that represents the new filters. And then to close it all up, I can subscribe my latest filters subject to it, so that now my latest filters subject might not have been the best naming choice, but it is what it is. Now latest filters also emits the value of the latest filters at the same time, or roughly the same time, that this pipeline emits it. Okay, so I'm going to take that, I'm going to hook that back into my data, and you'll see here, this is the same function we looked at before, but there's also a little pipeline that I ignored before. Again, I'm using with latest from, and I get the value of the latest filters stream. And again, I'm using map. I have the latest filters, I have my data. I can use the latest filters to tell my data either pass the negative sentiment or don't pass the negative sentiment down to my UI. Same for positive and same for neutral. And actually, this construct, this sort of cycle, is the way that we have in RxJS to sort of remember. Because sometimes we do need to remember. We don't need our data to be static all the time, but we need to remember what happened before. And so what we do in order to model that is often this combination of subject and observable, where there's like kind of a cyclical, it's not exactly cyclical, but the subject is subscribed to the observable, but the observable also uses the subject. Perfect timing, because it's the end. Okay. I want to summarize. I want to say something before I summarize. I know that RxJS code can be difficult to get into. It's very, very different from basically, I think, anything else we work with. And I think one of the reasons, or maybe even the main reason that it's so different, is because it requires a change in the way we think. We're so used to setting up our data as static, and then you go in and you know what changes it, and you build the thing, and you did it. And here, that's just not how it works. We set up these pipelines, and we trust that the data will flow through them. But even if the code wasn't 100% clear, and I'll give you access to the repo, you can look at this code, you can play with it, but even if the code wasn't 100% clear, I hope that the idea makes sense. And I hope that this idea of modeling data as being dynamic, as changing over time, modeling our apps as events and reactions, I hope it's clear why this is a better way to model front-end applications. So thank you. Twitter, thank you. I'm outside, so if anybody wants to ask questions or look at the code, which so far the MacBook is doing fine, feel free to find me. Thanks.